Hey guys, it's Mr. Wilmot here. This video is going to be talking about AC waveform in regards to period and frequency. We're going to talk about what period and frequency is, or what they are, and how we calculate those. Hopefully you guys should have watched the video right before this that talks about the difference between DC and AC, since up until this point we have only done DC circuits. So now we're kind of jumping right into AC circuits. Okay, so to kind of make sense of that, you need to watch the difference between DC and AC video before this. But otherwise, if you didn't watch that, go back and watch it. If you have watched it, then keep on with this video and we will continue on. So, sine wave alternations and cycles. This line here is our zero, meaning zero voltage or current. Okay, and as we go above the line, we're looking at positive voltage and current, and when we enter the bottom side of the zero, we're looking at the negative voltage and current. This is called our positive alternation, and this is called our negative alternation. And together, where it starts in the positive alternation and ends at the negative alternation, this is called one cycle. Okay, in other words, it's the part of a periodic waveform that does not repeat itself. Okay, so this is one cycle, and this would typically continue on to a second cycle. So this is kind of an example of what I'm talking about there. There's one cycle, there's the end of it, it starts the next one, there's cycle 2 and cycle 3. Okay, so this graph, okay, let's talk about the graph itself. First of all, these squares, we call them divisions. Okay, so right now, if we look at our horizontal axis, which is time, every 2 divisions is 0.25 seconds. And over here, this would be a voltage. Okay, we have our positive voltage above 0, our negative voltage below 0. So this would be at the top of this line is 2 volts, positive 2 volts, and at the bottom of the line would be negative 2 volts. Okay, and we were just talking about our cycles, so I already have labeled each cycle here. There's 4 cycles total. So this is starting at 0 into our negative alternation, going across the 0 into our positive alternation, and then stopping right here for our first cycle, and then starting over again. Okay, so period, which we use the capital letter T, is the time required to complete one cycle. Okay, so the time to just do this one cycle. Okay, and period is measured in seconds. So in this case, this one cycle, okay, if we look at our units, which is 2 divisions long, would be 0.25 seconds. So the period of this waveform is 0.25 seconds. And in other words, our period equals 0.25 seconds. Frequency. Okay, frequency is the number of cycles completed in 1 second. Okay, so that's how many cycles in 1 second are there. And by the way, frequency is measured in hertz. So in this case, again, it's the same graph we were just looking at. There are 1, 2, 3, 4 cycles on this graph, which is 1 full second long. Okay, so you can see we have 0.25 seconds, 0.5 seconds, 0.75 seconds, and this would be 1 second right here at the end. So that's 4 cycles in one sentence. Sorry, in one second. So the frequency of this waveform is 4 hertz. Okay, hopefully that makes sense. There's 4 cycles in 1 second. Okay, that's how we figured out what that frequency was. That's how we know that this waveform is 4 hertz. Okay, next we're going to talk about the formulas, how you can calculate frequency and period if you know one of them. In other words, if you know what the frequency is, you can calculate the period, or if you know what the period is, you can calculate the frequency. Okay, first of all, they're mathematical opposites of one another. So in other words, frequency equals 1 over the period, and period equals 1 over the frequency. So again, like I said, if you know what your period is, you can calculate for your frequency. If you know what your frequency is, you can calculate your period. And now we're going to kind of do a couple practice calculations using these two formulas, but it's fairly simple. So calculate the frequency of the waveform above if the period is 3.2 milliseconds. So we don't even need to calculate, like count the divisions and figure out, because we already know that the period is 3.2 milliseconds. So all we're going to do is use this formula and input the value for the period. Put that in your calculator, so 1 over 3.2 milliseconds, and you'll get a frequency of 312.5 hertz. Okay, again, pretty simple. Okay, so if you want to go ahead and give this a shot, this one says calculate the frequency of the waveform above if the period is 6.7 microseconds. So you can go ahead and pause the video and give it a shot. Otherwise, I'll just keep on moving on. Again, we'll use this formula. We're going to input the period, and frequency equals, if you put this in your calculator, 149.3 kilohertz. Okay, it's really important to notice the units, right? This is microseconds, and then if you put that in correctly in your calculator, you're going to get an answer in kilohertz. Okay, microseconds is different than milliseconds. Obviously, if you put in 6.7 milliseconds, you're going to get a much different answer than 149.3 kilohertz. Okay, moving on. This time, we're going to calculate the period. Okay, so if the waveform above has a frequency of 250 hertz, we're looking at this formula. Period equals 1 over 250 hertz. In this case, we get a period equals 4 milliseconds. Okay. Now you go ahead and give this one a shot. Okay, you're going to use that formula. You're going to put it in. 400 kilohertz equals a period of 2.5 microseconds. I went ahead a little quicker than I wanted to, but you guys should get the gist by now. It's pretty simple. So this time, we're going to count. We're going to count the divisions. Okay? So calculate the period and frequency if the horizontal scale is 2 milliseconds per division. That means each one of these squares is 2 milliseconds. Okay, so in this case, let's look at where our cycle is. So we have our cycle begins here and ends right here. And what we're going to do is count how many divisions there are. Okay, 1, 2, 3, 4, 5 divisions. Okay, so our period equals the scale, which is 2 milliseconds per division, times the number of division. So that would be 2 milliseconds times 5 divisions, which would give us a period of 10 milliseconds. And now that we know the period, we can calculate using this formula here what our frequency would be, which in this case is 100 hertz. Okay. Here's another one. This one has a horizontal scale of 10 microseconds per division. Okay, this one's going to be a little bit trickier because the sine wave doesn't fall perfectly on the start or end of divisions. So I'm going to kind of start down here towards the back end of this waveform because this one starts right at the start of this division and ends kind of in the middle of this one over here. So let's count our divisions. We have 1 division, 2 division, 3 division, and this is actually just above half of a division. So we're going to say 3.6 divisions. Okay, so same thing, 10 microseconds per division. times 3.6 divisions. So our period equals 36 microseconds. To find frequency, we're going to use this formula. We're going to input the period, and we're going to get a frequency of 27.8 kilohertz. Okay, so go ahead and try this one. Alright, I'll let you kind of try it on your own, and go ahead and pause the video if you want, and give it a shot. Otherwise, like I said, I'm going to just keep on moving on. So here I chose 2.4 divisions for the cycle, which using that gave me a period of 120 nanoseconds. And if you input that into our formula, you'll end up with a frequency of about 8.3 megahertz. Okay, hopefully that makes sense to you guys. If you have questions, you can email me, let me know. But if you took good notes and you kind of worked along with me, you should have no problem with the quiz. All right, take care, guys.